My name is Emma. This is my final presentation about Smart Parcel Locker. And this presentation, this is all information that I will share with all of you. And let's start the presentation. For the information, the problem statement is customer access code failure. And the motivation, my motivation is to give the last mile delivery and go above beyond service for the customer. And for the background, as field quality student at Amazon, I frequently receive a report from the customer that they get some issue to access a locker door. So in response to this issue, I have initiated to investigate the root cause of this failure for the Captain project by analyzing the system work for any irregularities in the code generation procedure. So since we're talking about the code which has correlation with RFID, that RFID stands for radio frequency identification, where RFID offer more advanced security to the traditional system of smart locker. However, this does not rule out that RFID system with some security issue and vulnerability. That makes me wondering and want to find out if there is any correlation between RFID encryption and code delivery to the value of the code retrieval. So that's cover all the backgrounds. Let's move on to the approach or user requirement. The primary user for this project is the recipient who interact with Smart Locker based on field observation at Amazon Logistics. And for the design itself, the design you have a three-tier architecture, which is locker hardware that consists of RFID reader, microcontroller, and keypad or display unit. And the second middleware layer that responsible for secure code generation. And the third is cloud for user management. And for the implementation, I believe this is the same like a technology I use. So since my access to the real environment like Amazon Locker is limited, so I'll be utilizing a BAS44 to simulate a Locker dashboard, one-time access input code with prototype by Walkway, and the notification service dispatching code through SMS and email by Twilio. So this brings us to our next crucial point, which is the dashboard simulation environment by BAS44. So as the locker administrator, first thing, I will invite the user with send them email invitation. After they email accept the email invitation, then I can create a user information over here to send a code retrieval with an expiration. So just in case to illustrate what the dashboard look like after creating a user name and send them active code, it will be information over here. This is the password and this is an active code. If the code is inactive, it will be gray out. So now let's shift our focus to the next, the hardware layer by walkway simulation, which include an RFID reader, a microcontroller, and a keypad. So it's a really nice improvement to test the physical fallback pathway without the software notification pipeline. So the data from this source will include RFID text scan success, a second locker door release latency, third number of scan attempts, and the last system behavior when an invalid code presented. So in the next slide, we will watch all the demo from the start to the last part, which how to create a user and code, and then send them through SMS by Twilio, and then how to use this RFID to the locker log. Let's say this one. The first thing, this is dashboard look like. If this is simulation, okay. The first thing, this is a user. The first time I'll invite the user and then I enter an email, let's say this my, and then I'll be a user here and then I use a user because there is two option, either admin or user because I'm user, I use a user and I invite. And over here, the user. Let's say I accepted this invitation. This is turn to send the locker code. And then this one, let's say locker code. The code, I set up 1, 2, 3, 4. The tab is like a password. There is a note, maybe this is the note. Your locker verification code is 1, 2, 3, 4. And then this is expiration date, usually 3 to 4 days to retrieve the package, and then submit. And then this all over here for the verification. After this, let's say all this code delivered by Twilio. I do have two examples here. First, a virtual phone. Let's say this is verify a number. And then let's see. And then the other one is unverified number example. Let's say the verified number, this is one, just the number, this is your locker code verification, code is 1, 2, 3, 4. We will see, send, what will happen. There you go. There is an information that SMS or the code has already been delivered, success. And then one more time, this is unverified number. This is my number, by this one, and then send the same thing code, and then what will happen. There you go. There is an information that it's failure because toll-free number has not been verified. Let's say the code is being success delivered to the user. And then this is time, me as the user, go to the locker and try to type the code. Let's start this one. We'll see. This is like imagine the locker lock over here. So in the locker code, let's say 1, 2, 3, 4. What happened? The code is open, which means the locker code is open. And then let it close. Let's close it back. And then we will see if we put the wrong number, 1, 2, 3, 5. They don't want to open. This is like 10 seconds to wait. Okay. And then, okay, that's all the demo I can share. Let's go back to the finding. With the finding, I have 3 points that the code retrieval failure cannot be solved by captive grab alone, which is the 85 delivery success rate remain constant whether or not that captive grab was enabled. So we can see the demo that the failure caused by the notification infrastructure issue, getaway timeout, and email routing error, unverified phone number or email. And the second, RFID with two-factor verification outperformed the digital channel on both speed and reliability. By the test, 96.7, authentication success rate, latency less than a second approach. And we will see that the sole error in the authentication was caused by physical misalignment, like inaccurate code or had been expired. And then the last is access equity consideration require both technical and policy responses, which is the locker system is have to be fair, usable, and accessible to everyone, regardless of their physical ability. Equity also depend on interface design. And it goes to the conclusion, or all this all together, the custom project set out to answer why do smart parcel locker fail to access code and what can be done about it? So the answer that emerged from the design, simulation, and analysis work. So the code retrieval, I can say, failure is layered by cryptographic and structural human and any solution. So if we're talking about what correlation between code failure with encryption, the code can be perfectly encrypted and still never reach the user or cannot be used. So that's why all this finding give me one takeaway that RFID is working entirely outside the digital notification stack. It has 96.7 authentication success. Also, it correctly rejects an authorized credential that demonstrating both reliability and resilience. And on the last part, building on the last point, we also need to consider the locker interface itself as a future work that deserves attention as a future design problem. When I focus on the backend security and access pathway, but I realized that the front end, where the screen, the user start at where they arrive at the locker, is where equity lies in practice. So my future work, I could explore adaptive UI approaches like dynamic font sizing, voice guidance, multilingual, and simplified instruction for the first-time user. So that's all the bridging the gap between identifying an issue and retrieving its root cause. And then thank you for all your attention. I would love to open up for feedback or answer any question you may have. That's all my presentation, and thank you.
What made you decided to pick that particular project?
No, because I work with this every day. I do have escalation for a bunch of customers, not bunch of customer, but I often that they do have a code, but they don't they cannot use the code in a way, use the code, or they don't have a code to retrieve a packet. So that's why I just want to make sure what happened. But the thing is, because my limited access to the real environment in Amazon, everything used virtually or simulation, but I think it's almost the same. When I see how it works, I can access the code, but the thing I cannot access the credential of the user because that's confidential. That's the thing. But all this step, all this process, similar, almost the same, 99%. That's why I took this one.
Thank you, Emma. Do
Yes,
Tyler or Joel, do you guys have any question for Emma?
I have one real quick. It was really cool. It
sure.
was the Arduino simulator. What was the name of that program again? I forgot.
Which one, the RFID or the dashboard
For
or the
the
three-layer?
I think it was the RFID thing.
Oh, this is Walkway. This one? Walkway?
Okay, that's cool. Can it also do Raspberry Pi?
Pardon me?
Can it also do a Raspberry Pi instead of an Arduino board?
Oh, I have to buy that if I want to.
Oh, you'd have to buy it? Oh, okay,
Mm-hmm.
that's cool. I like that
Mm-hmm.
because it like subverts the need to actually get the real hardware. That's awesome. Good job.
Yeah, it is. That's why. That's why I'm lucky get this one because it's not connecting to any software anywhere. But if I want to connecting, I have to buy those.
I
But
gotcha.
it works similar like the locker work, the job desk did, like this. It's similar like that.
Cool.
So even I can change the code. Okay, go ahead. Is there any question? Someone else? Another one? We can talk about everybody later, Joel, maybe.
Yeah, that's awesome.
Yeah,
Good
if
job.
you like it.
Very cool. And Tyler, did you have anything?
Oh, no, I do not. It was a very good presentation, though.
Yeah,
Thank
great
you,
work.
Tyler. Thank you, Joel.
Good job.
I'm into bed. I'm like running.
Nah, you killed it. You're good.
Yeah,
Thank
thank
you,
you,
Joel.
Emma.
You're welcome, Meg. Thank you.